Okay, this is a nice one. Exercise 16.03, question 7. Again, we're making x the subject. So to start with, I want to get rid of the denominator. This is a difficult thing to deal with a denominator. So we're going to extend the vinculum, and I'm going to multiply the denominator, which is x plus 3, to both sides. X plus 3. Here we go. So x plus 3 divided by x plus 3 is 1. So I'm going to expand this out on this side, which is going to be x times y is xy, 3 times y is plus 3y is equal to, I've got an x plus 2 on this side. Now, I really want to get rid of the 3y. I want to keep all the x's on the left and everything else, including the 2 and any coefficients on the right. So let's subtract 3y from both sides. There it is. 3y minus 3y is 0. I've got xy is equal to x plus 2 minus 3y. Now, sorry, you can't see that. I'm going to subtract x from both sides because I want to keep x on the left side. It's gone now on the right. So now I've got xy minus x. So on this side, though, I'm just left with 2 minus 3y. But on this side, I'm able to now factorize this. I'm going to say, well, what's common to this and this? Well, what's common is x. So what times x makes xy? Well, y is. What times x makes negative x? Well, negative 1 is. So let's take a shot at this. I'm now going to divide both sides by y minus 1, y minus 1, and y minus 1 divided by y minus 1 is 1, and 1 times x is x. And now I've got 2 minus 3y over y minus 1. Well, that's actually a perfectly good answer. However, I'd like the 3y up front. So I'm actually going to multiply but all of this by negative 1. I'm going to multiply all of that by negative 1 and all of that by negative 1. I don't have to do this, but I prefer to have the 3y at the front. But then I'm going to have y minus 1. It doesn't really matter. I'll try it though. So this becomes now negative 3y becomes positive 3y. 2 becomes negative 2. And then I'm going to have positive 1 now minus a y. And there is my final solution. Either would have been perfectly okay though.